When a major shipping lane is blocked or a key port closes, the pulse of global trade seems to stutter. Ships wait at anchor, containers pile up on docks, and headlines warn of impending shortages. Yet, within days or weeks, the world's vast commercial system continues its hum. Goods still move from factories to consumers. The initial crisis appears to resolve itself. However, a closer look reveals a curious and lasting transformation. The flows of goods do not simply resume their old paths. Instead, trade routes subtly but permanently change. New factories begin shipping to different ports, and prices adjust in some markets, but remain stable in others. First, we outline the visible problem, then reveal the hidden mechanisms, and finally, the system effects that few see coming. At first glance, a disruption in the global supply chain presents a clear and straightforward problem. A vital factory cannot obtain a specific raw material needed for production. A retail store in one country runs out of a popular product manufactured in another. The immediate cause seems obvious. A ship is stuck. A border is closed. A natural disaster has halted operations at a key facility. The observable effect is a gap in the flow of goods. Firms scramble to find backups. They call alternative suppliers. They try to secure components or finished products from different sources, even if more expensive. These immediate actions are a visible and important part of the story. Companies pay significant premiums to reroute goods through different channels. Some shift from sea freight. Others use faster but costlier air cargo. They divert trucks hundreds of miles to bypass obstacles, a closed bridge, a congested checkpoint. These reactive measures are the frontline defense against a trade shock. They explain how urgent short-term gaps are filled and why the global economy doesn't completely stop. These tactical adjustments are logical, necessary, and show firm-level resilience. Yet, this flurry of activity doesn't explain deeper, more permanent changes after major disruptions. Short-term fixes are like applying a bandage to a wound. They treat the immediate symptom but not the underlying healing that can leave a permanent scar. Why do trade patterns remain different for months or years after the problem is resolved? If a closed port reopens, why doesn't all its former traffic return? The simple explanation, firms finding backups, is insufficient. It treats the network as interchangeable paths, chosen by cost alone. The reality: the global trade network isn't a simple map with infinite options. It's a highly structured system with inertia and limits. The surface-level view of rerouting misses fundamental constraints on choices. It overlooks contractual obligations that bind firms to partners. It overlooks the lack of information that clouds decisions. To see why a temporary shock can cause lasting shifts, we must move beyond the visible blocked route and the simple "find another fix." We must investigate the hidden architecture of the network, where deeper forces are at work. The first and most significant hidden factor that shapes the response to a trade shock is physical capacity. Not every port, road, and rail line can absorb a sudden influx of traffic. When a primary route experiences a closure, Suez Canal, Port of Shanghai, diverted ships and cargo cannot simply appear at the next closest port without consequence. Alternative ports may already be operating near their maximum capacity. Cranes, storage yards, and the workforce may not be able to handle a sudden surge in volume. A second hidden constraint is the web of contracts and established relationships. International trade does not operate like a spot market. It runs on long-term agreements and meticulously planned schedules. A manufacturer signs a contract months or even a year in advance, specifying volumes, prices, and delivery dates. Shipping lines and insurance policies are arranged based on these agreements. When a disruption occurs, these legal and financial commitments create powerful inertia. A firm may be unable to switch suppliers or shipping routes immediately without breaching a contract and incurring financial penalties, forcing it to wait for a renewal window before making a change. A third, equally important hidden factor is the imperfect flow of information. In a complex global system, no single actor has a complete picture of the situation. A local manager may hear a rumor of a shutdown, but headquarters may not know how long it will last. News about port congestion, road closures can be delayed, contradictory, or incomplete. Incentives are the engine of change within the trade network. In normal times, the primary incentive is to minimize cost while maintaining a reliable supply of goods. This creates highly efficient, lean supply chains for a predictable world. However, a trade shock dramatically alters incentives. The balance between cost, speed, and risk shifts overnight. Suddenly, the cheapest route is no longer the best if it's blocked or unreliable. The imperative to avoid a costly factory shutdown or to prevent empty store shelves becomes dominant, pushing cost into the background. After a shock, reducing risk becomes paramount. Firms that relied on a single supplier in one country are exposed to massive vulnerability. The new incentive is to build resilience. This translates into diversification. Companies seek multiple suppliers across regions. They may choose a second supplier that's more expensive, but in a more stable location, treating the cost as insurance. This shift alters demand, creating opportunities in previously overlooked regions. Another incentive is a premium on speed and flexibility. When a critical component is delayed, an assembly line going idle can be astronomical. Paying more for expedited air freight becomes rational. The dimension of time is crucial in determining whether a change in trade patterns becomes permanent. Every significant adjustment in a supply chain involves a time lag. Building a new factory, for example, is not an overnight process. It can take several years from planning to production. Signing a long-term contract with a new, large-scale supplier requires months of negotiation and quality verification. Rerouting shipments through a different port involves administrative delays, new customs procedures, and logistics partnerships. These inherent delays mean that the duration of a disruption is a critical factor. A short-lived shock may end before any long-term adjustments can be implemented. If a disruption persists for an extended period or is expected to recur, firms gain the motivation and time to make substantial investments. A one-week port closure might only cause temporary rerouting, but repeated closures from labor strikes or weather make the port look unreliable. A small temporary detour can be tested, reinforced, and eventually integrated as a primary route. This is governed by thresholds, critical tipping points in the system. A secondary highway or smaller port may handle small increases in traffic, but if diverted volumes cross a threshold, congestion triggers change. If traffic exceeds design capacity, authorities may invest, widening lanes, improving intersections. Once built, capacity rises, costs fall, and the improved route stays attractive even after the disruption ends. Once a trade network begins to shift, feedback loops often determine whether the changes grow and become permanent or fade away. A positive feedback loop is a process where a change creates effects that amplify the original change. After a disruption, a few companies may experimentally reroute through a smaller port. As traffic rises modestly, it gains revenue and experience. This might lead to investment in new cranes, deeper channels, more efficient customs. Improved service draws more shipping lines and businesses. This cycle is a classic positive feedback loop. Over time, it can transform a minor port into a major regional hub. The rerouting of trade networks has consequences that extend far beyond the balance sheets of individual firms. These shifts ripple through economies, affecting jobs, infrastructure, and regional development. When a new port becomes a hub due to a positive feedback loop, it creates a localized economic boom. Jobs are created not just for dock workers, crane operators, trucking, warehousing, logistics management, and customs brokerage. The surrounding region benefits from increased investment and economic activity. Conversely, a port or region that loses its position may face decline, job losses, and underutilized infrastructure. A prolonged drought lowers water levels in a critical inland waterway, making it impassable for large barges. Cargo that once moved cheaply by water is forced onto rail and truck networks. As the drought persists, railways expand capacity and new trucking depots are built. Years later, a land-based logistics ecosystem has formed that keeps a significant share of traffic even when rivers recover. The shock permanently altered the region's economic geography. Another clear example involves a specialized semiconductor chip. Imagine an earthquake halts production at the world's primary manufacturing site. Firms begin a frantic search for alternatives. Some pay premium prices for limited remaining inventory. Others start a multi-year redesign to use a more common chip. A few co-invest in a new fabrication plant in another country. Once online, supply diversifies across 2 locations, increasing global resilience and shifting high-value industry. Rerouting from efficient sea freight to air or road can significantly increase carbon emissions. New trade hubs alter strategic dependencies, influencing foreign policy and relations. Policymakers must anticipate investments where flows are moving and support regions that risk being left behind. The hidden rerouting of trade is the constant, subtle redrawing of the global economic map, and those redraws begin with mechanisms we can see. The central insight is that global trade networks are not static maps with fixed routes like a highway atlas. They are living, adaptive systems. Structure is defined by flows shaped by complex rules, not by lines on a page. A disruption acts as a stress test that reveals those rules, creating disequilibrium and forcing a new balance. Lasting change comes from the cascade of choices made afterward. Choices are guided by capacity limits, contractual rigidities, imperfect information, and shifting incentives. Speed and permanence depend on time lags, critical thresholds, and feedback loops. A small detour can trigger investment and a positive loop that locks in a new route. Proactive managers map vulnerabilities, bottlenecks, and contract windows, investing in flexibility before shocks hit. Small investments in options and redundancy enhance long-term resilience. You've been watching System Atlas, exploring how the world's systems really work. Share your comments below. See you in our next episode.